So now we're going to see some more examples of functions, and we're going to discuss the concepts of domain and range. All right. So given a function f of x, f comes with a domain and a range. The domain of f is a set of possible inputs to the function. Now for us, the inputs will always be numbers, as will the outputs, but sometimes you can plug in certain numbers, whereas sometimes you can't plug in other numbers. So we'll see examples of functions which have different domains in a second. The range of f is the set of all possible outputs. Now, finding the domain of f is often very easy. Finding the range of f can actually be kind of difficult, and so most of the time we won't be able to figure it out, and you won't be asked to figure it out. But I'm going to show you an example where we can figure it out, a very simple example. Alright, so here's our first example. F of x equals x squared plus 2x plus 1. Okay, so I'm not going to discuss the range of f, but I can talk about the domain. And here, the domain of f, this is how you should write it, dom parentheses f. The domain of f is equal to minus infinity to infinity. Think of this as the interval notation we discussed last time, which contains all real numbers. If you were to shade this on a number line, you would get every number in there. And so what that means, conceptually, is that we can plug in any number to f, and it will give us a valid output. So the possible inputs for f are all real numbers, any number you can plug into f. And why? Well, you can take any number and square it, and multiply it by 2, and add it. And you can add any numbers, right? So there's no problems. And that's really how you should think of domain. When you want to find the domain, you look for the potential problems in your expression for the function. So here's an example up here where the domain is not all real numbers. We have g of x equals x squared plus 2 divided by x minus 3. Now, we want to determine the domain of g, so we say, what are the potential problems with the expression for g? Well, there's no problem with the top here. You can always square a number and add 2. And on the bottom, you can always subtract 3 from a number. But sometimes, if, for example, we put 3 in on the bottom, then we would have to divide by 0. And that's bad. So that's one of the examples, one of the main examples where your domain will not be all real numbers, is when you might divide by 0. So here, any number works except for 3. So the domain of g is all real numbers except 3. The way you could write this in interval notation is as minus infinity to 3. Notice we're excluding 3 here, since we have this parenthesis and not the bracket. Union, that's what this little u symbol means. That means we're taking these two things together. So union 3 to infinity. Notice that again we're excluding 3 because we want real numbers except for 3. And so if you think about this set here, if you pick any number that's not 3, it's contained in one of these pieces. And so the only thing we're excluding is 3, which is what we want. Now, if you don't like this notation, if this is too confusing for you right now, it may be easier to just say that the domain is x is not equal to 3. That's another way of saying the same things here. Okay, now for one final example, we have the function h of x equals 17. Now first you have to think about what this means. What this function means is that no matter what input you give it, the thing it gives you back, the output it gives you back, is simply the number 17. So h of 0 is 17. H of 2000 is 17. All right, let me write those out. H of 0 is 17, because when we hand h the number 0, the output it gives us back is just 17. The same thing for h of 2000. That's also equal to 17. So now we're going to discuss the domain for h. Well, there's no problems with plugging anything in for h. No matter what I give it, it gives me back 17. So the domain will be all real numbers. Right? Another way to think about it, this expression, h of x equals 17, there's no problems with this side, right? You're never dividing by 0. You're never taking the square root of a negative number. These are sort of problem areas, and none of them appear over here. Now, this function, because it's very simple, we can actually determine the range of h. So the range, remember, is a set of possible outputs. And here we see that no matter what we plug into h, it gives us back 17. So the range, the set of possible outputs, is simply 17. That's the only possible output. So this is one case where we can actually determine the range of the function, because it's a very simple function.